Good day.
Hello, Marcin. How are you?
Doing all right. Did you get a chance to talk to your summit friend?
I haven't got an answer yet,
Okay.
but for
Okay.
sure I should get it this week.
Okay. Let's do a little 5 minutes of meta. So go to my log, and I started writing some notes about rapid learning pedagogy. So this is the kind of stuff that we're doing, or I want to do. MJ log, or just type in MJ in a wiki.
Yeah.
Let me know when you see it.
I'm here.
Okay, cool. I'm just I got a quick question though on your log. So you logged like 20 hours or so, like October 20. But after October 27, I haven't seen anything. October 27, just in terms of your time, is that you just didn't get to it, or?
I just didn't log the time because if I do an analysis, at least I've been doing 6 hours per day, and that's at least.
Yeah. I mean, hey, if that's gonna be open source, put those hours down. If it's gonna contribute to the world, put it in a log, because it's the due diligence you're doing. Okay, because it is contributing to that. Okay, so if you looking at the rapid learning OSC rapid learning pedagogy, click on that. I want you to kind of take a look at it, and maybe we could actually keep evolving these notes here.
What's the name again of?
Yeah, so click on the first link in my log today.
Uh,
Got it? OSC. So
yes,
OSC rapid learning pedagogy.
yes.
Let's filter our process that we're going through right now and see if it fits this. So, because as we go forward, I want to make sure that people are approaching rapid learning like in a big picture perspective. So let's see if this is actually, and I'm trying to summarize that for people so they get their head around the idea of what rapid learning really means and how they could expand their ability. So let's see if this makes sense, and these 10 or so points are relevant by applying that. Okay, what we're doing right now with the blueberries open source development here, does that actually fit this kind of model? Just let's do this for like just 5 minutes. Okay, so always approach any learning process from a multi-intelligence and multi-literacy approach. For example, approach building from intellectual, kinesthetic, auditory, spiritual, visual, quantitative, financial, oracy, such as communicating with others. So there's spellings there. Draw up things like mind maps to help you wrap the whole project. So are you doing one in this process? What you're doing right now with the blueberries?
I would say yes. Most of the concepts is something we're doing on that Word document and on the spreadsheets as well.
Mm-hmm. Is that a useful, like if we say that if we want to do rapid learning, we use multiple intelligences. Is that a good framework to talk to people about? Like, because somebody might say, oh well, I just want to read it, or just think about it. But a lot of times people don't think that, oh, there's all these other skills that you already have or capacities that you already have that can help you learn.
You're asking me if that has been good for my work?
Well, what I'm asking is that an important thing to bring up to people, to explain to people as they're, for example, with the 4-year program and at OSC, is that a good framework to get them thinking about, or is that not an important point?
On my experience, is very important. Getting the whole visualization of the entire process. So to be able to learn how to put it in single components, first fundamentals, and from there going into really designing something that you need, not what is already there.
Mm-hmm. Okay, cool. Um, why don't you read 2 through 12 and then see if you like these points, or if I'm missing something, or if something is irrelevant. Okay, so just go through that. So number two, do you agree with that? Moral intelligence is the ultimate compass for productive versus destructive ends. Like, what are you doing? Like, what's the direction of what you're working on?
Yes, that's something elemental.
So,
Sometimes we think we understand what's moral intelligence or what's good and what's bad, and when you see the different components are explained here,
uh-huh.
it's a way to grow and to understand other philosophies. So I have a bigger perspective. That's what I got when I was reading moral intelligence, the different type of intelligence as well.
How does the approach that we're taking on display moral intelligence? What element of it displays it?
I would have to really analyze it again to be able to make the concept personal.
I would say the first thing is that first of all, we're sharing. We're not hiding this. This is public. That's moral intelligence, I would say.
Okay.
That's the first thing that comes to mind. Like we're actually trying to give to the world as a fundamental thing, which is a moral intelligence thing. It's that like we're trying to take care of everybody. Okay, so problem solving number three. Problem solving does not exist in a vacuum. If you understand the context, you have to understand the context, and then you want to bound the scope of the problem in your mind, such as a mind map. And I heard you express this already. Like last session, you already said, yeah, I'm going left and right to all the different elements because I'm bounding the problem to what all the elements of economic optimization are.
Yes, getting out of the silos mindset and being able to reconnect things.
Mm-hmm. Okay. Okay. How do we apply? Well, okay. So point. I don't know how we apply it right now, but you know that you understand something if you can explain it to a child. That's the Richard Feynman method. But I actually think that there's an element of that. Do you see a quick answer for that? Because I got an answer for that. Are we using that kind of approach here?
Probably working in slides with that kind of format, everything has to be so simple to explain just to be able to connect each phase. That has been my experience. We are not childs, but we are people with reduced time and reduced space. That's what I got.
Yeah, and I thought actually the thing where you tell me cost per plant, like you were telling me about all these acreages and the operation, but I just said, okay, let's do a basic unit, and that I think is an example of that kind of a pattern of thinking. Okay, use tools for knowledge management that time bind your whole life. For me, that's a journal and a wiki. Then learn how to index and organize so that anything, absolutely anything, is accessible to you within like minutes or seconds. That could include like personal searchable AIs or indexed wikis or journals or table of contents. I want to ask you, like, do you journal? Do you keep a journal?
Every day, yes.
Oh wow! So you're already time binding your life. You know the
Probably
word time binding?
like concentrating easy to access.
So time binding is a general semantics concept that says that humans are the only species that can build upon past experience to make a better future. Because we have memory, we have a way to record things, we have writing. That's called time binding. It's a big concept of just basically you take knowledge and then you build upon it to stand on the shoulders of giants. So I'm glad you're doing that. Do you think the wiki is relevant for you for that? Because I use the wiki, like for me, like I type in on the wiki all the time. I also do journal. But the wiki is like I can access any single piece of there from years ago, whenever, like whatever I wrote, I can pretty much find it within seconds.
Yes, it's relevant for the organization and also because of the updates. Let's say if I will be building a machinery and
Mm-hmm.
there's an update, it's the same site I'm going to access, but I'm just going to see the access to the update as well.
Yeah. Do you know any other tools that are any better than a wiki to do that kind of process?
On public domain, I would say no. On private domain, I would say clouds.
Clouds?
I mean, right now we're working on the slides and
Cloud.
spreadsheets, and that's on a cloud. That's what I meant.
Oh, like Google Docs and stuff.
Yes.
Mm-hmm. Okay. I mean, any specific part of the cloud? Can you point to any specific tools or no?
I would say that direct access, like as an example, being able to work on slides and on slides being able
Yeah.
to put the links on each concept and then click there and go directly to the
Yep.
answer I'm looking for on a specific topic, such as the blueberry snap.
Yeah. Yep. Yep. Exactly. Um, how are you on taking notes? Are you an avid note taker? Because point six is understand that human memory has limits. Like for example, in the presentations that I do, it's like if someone goes in there and they don't take notes, they're just there like like passing time. That's my opinion of that, because you're gonna forget just about everything. Maybe you'll retain like 1%, like maybe one little thing. But if you want to get more than 1% or zero, then take notes. Do you take notes regularly or?
I do, but what I'm doing now that helps a lot is that these videos are recorded. So I just go back to YouTube and I
Oh, there you
watch
go.
them again every week. I'm doing that just to be very sure on what I talk about and all the different tasks that are pending for next call.
Oh, excellent. So I'm just gonna add, if you don't take notes, just record videos. Uh, or record videos. Yeah, excellent, excellent. I have a mentor who I talk to. I review his stuff all the time, so that's good. Or record videos. I'm glad you're doing it. I'm glad you find it useful
Yes,
enough that.
I do take notes, but I'm also taking some pictures and taking videos. And as an example on plants, I'm not just trusting what I wrote. I take videos with a drone, so I have the recording of each week, and that's a way to really be comparing and accessing the reality during the season.
Yeah, that's cool. That's cool. Um, I next one. Create your own genius network or learning community. This is people who know stuff and who can teach you immediately. So we've got an example of a genius network right here. We're both teaching each other. You got stuff that I think about it as that is my mentor or any subject matter experts that we bring on board. Anyone who's spiritually grounded to share, meaning that they can share their knowledge freely. That's the open source genius network that I think is an extremely powerful concept. Yeah, I hear you talking about mentors as well, and that's good. Um, do you have any other ideas of how to nurture the genius network?
As of now, I think time would be the answer when we get the rest of the people doing this kind of study.
You talking about apprentices?
Correct.
Oh yeah, that's going to be our genius network. Yep. Right now I'm thinking, man. Oh, a little aside on that. We got to so here's the numbers. 20 million views, about 200 interactions on people signing up for the workshop. Probably about 40 or 50 are signed up already. For the apprenticeship, 3 people filed applications. There's something wrong with that. So we got to get that right. And I'm thinking the idea where we scholarship people, we give them a stipend as an option, like that would, I think, go a long way, because I think a lot of people can't afford it. I think the way we got to be super clear is 2028, there's 50 machines, 24 cohort per. That's 1,000 people. So that's my new clarity on this. By 2028, there's 1,000 people at Factory Farm, permanent, like students. So if we can do 24, we got to scale that as fast as possible. For example, we're doing the advanced 3D printing. Okay, you need yourself a cohort of 24 to make that commercial feasible, like within rapid timescales. Anything is really $1 million development budget, and that's like skunk works. So yeah, but we got to talk about those numbers. The bodies are what matters. It's not the funding. We can bootstrap with the cash from the home sales. By the way, so we're under contract. So the house in Maysville, 219K. So that's going to be closing December 15. So that's a real good proof point. Okay, we're moving forward. Okay, cool. Okay, point number 8, contribute to open source so your know-how translates globally. And open source, I mean, to me, that's like the ultimate moral intelligence thing. But open source means that if everyone thought like that, then all the knowledge from everywhere would be accessible to me. Like if I'm greedy for knowledge, like I want to learn, I want to be a learning machine. So that's why we got to do open source, right?
Yes.
Any comments on that? I mean, you that's how I see you perceiving the world.
Yes, that's the way to go.
Yeah, yeah. Okay. Do not learn point 9. Do not learn items. Learn patterns, modules, elements, primitives, construction sets, so that your learning is generative. So, like, if you learn how to do, we end up creating a simple idea is like tractor construction set or housing construction set. You can create any kind of a house, not just like one house. Or if you understand the elements, or you're a chemist in principle, you know how to mix all the elements. You can create any substance. So learn the fundamental things. Just like for all of technology, there's about 500 basic modules, like a spring, a lever, an actuator, like wheel. There's like 500 elements, and some of them get more complex. But that's how I like to study this, so that if you want to talk about open sourcing the technosphere, you work on the principles of what are the elements, so that you can design anything. Because you'll see that, like for example, if you talk about hydraulics or like, well, piston. A piston could be an engine. It could be a hydraulic pump. It could be a certain type of a hydraulic motor. It could be whatever, a syringe. So you see that one element is present in so many different things. Or like a super high pressure hydrogen compressor, hydrogen booster. There's a piston in there too. So if you understand a piston, you've got all this technology underneath you. So that's why I emphasize this construction set, an elemental approach, module based. That's core. I don't see how we can really learn genius without that kind of an approach. Any thoughts on that one?
I was thinking about the 3D printers and plastics. Mastering those two materials would really develop a lot of things. Just going back to learn patterns, with these two kind of knowledge and materials, I could almost build 70% of what I'm doing now.
Oh yeah,
And that's a pattern.
yeah. You're saying that a 3D printer is so flexible because we already talked about insulation, growing medium, structural stuff, netting, like open source desalination, all that kind of stuff. Yeah, yeah. True. Yep, exactly. Number 10, learn by teaching. Needless to say, learn applied and hands-on. But the number one thing about pedagogy that I hear about, it's not even about experiential learning. The number one way to learn is by teaching. That's what I think it happens. That's why in this program I'm going to learn the most, because I'm trying to teach in the overall academy and stuff. Yeah. Oh yeah. So incentives. However we set up our program, if it's the apprenticeship, when learning or teaching, be clear about incentives. If the intended result is not happening, don't question the situation. Question your incentives. Are your incentives correct? So, for example, I mean, what is the best incentive structure for the apprenticeship? Is it about freedom? Livelihood goals? What is it? I mean, I don't know. I mean, I think it's highly related to freedom, transformation. I mean, those are kind of like those higher Maslow pyramid things. But do we also incentivize for like, what is the key incentive we have to build into the apprenticeship to make the bodies happen?
Capacity building, in my perspective. And you can say freedom, but freedom of what? Capacity building, I mean, to own a house so you can build it, own a business. You can do construction, you can do agriculture, you can do the jobs that are not going to disappear into this evolution of AI. Because basically, understanding electricity, understanding water, understanding material printing, as an example of many things that are physical hardware construction, those are the capacities that are not going to go away with any technology that develops. I
Exactly.
understand that there are AIs, which they do a lot of things, and there might be robots in the future, but most capacities that are not going to disappear are the ones I mentioned a few sentences ago.
Mm-hmm.
And that's on hardware, and that's on structuring real materials, real work that is made with your hands.
So how do we communicate capacity building in an apprenticeship? What's the best way to communicate that? I mean, that's
With,
all that we talk about, but it's like, how do we get that point across super clear?
with shiny things like money. What I mean by this is like the tractor example or the compressed air block machinery, like the document where you say, this is material cost, this is labor cost, this is open source cost versus competition, which is on the conventional market,
Mm-hmm.
and there's a very different margin. That's what I mean by shiny object, because we get attracted to money, and when we see a difference of price, that's very human to just get attracted and say, what's happening there? Is that good? Is it not? And then you find out more.
Shiny objects. Did I hear you correct? Money? You said money?
Well, I would say the comparative of the cost of doing your things open source versus conventional prices that you find on the current market. That's what I meant by money.
Open source versus conventional. Okay. I think that makes sense. Yeah, that. In fact, I mean, that's. Holy cow, if you think about it, that's how the viral video succeeded, right?
Correct.
Because we led with that. It's like, okay, bam. Okay, I'll think about that.
And that's what it got me here, being honest, when I saw the tractor price of building your own or building your
Huh.
own truck and that stuff. That's what I was able to see in my life, a big advantage of building this capacity in order to make more profitable business, or at least less risk on the business investments I would need to do. And also
Huh.
understanding things and being able to do it by yourself, it's a must, is much more secure than just doing the conventional way of
Yep.
spending a lot of money.
Yeah. Yep. Okay, explain this to me again. So with the house, we can tell you X dollars in, X dollars out. Now for the tractor, costs this much, industry standard is this much, but we're not producing that yet. So how are you able to see that yourself? So you see, okay, yes, I understand they're not producing it commercially, but it can be done. Is that what you said, or was that the thought process you had?
Correct.
Okay.
Exactly. That's it.
And you weren't discouraged by the fact that, oh well, because why I say this is there's a lot of people that are like, holy cow, I can't believe this, and then they look more and it's like, okay, well, where is it? Like, where do I buy one? Like, no, we don't have it for sale yet. And they're like, well, how do I build one? Well, here's our plans. You got to put in some real hard work and study to make it happen. And they get all disillusioned that, oh, it's not really there. You know, like, you see that?
I see that, and I would say the answer would be putting timeframes on what's already, sorry, what's already built. So you can see the CEV press, the compressed air block. I did it on certain amount of months, and I use these kind of systems to be able to do it in a precise output result. So I know there are many machinery that is already not built. It's not built yet, but with the systems that you had and the reference that you did with other machinery, you could do a projection of saying
Yeah.
the max amount with this kind of
Yeah.
task. If we do it systemized by this number of people doing this kind of work, that's gonna really give the vision that this can be made. It's just a thing of, I don't like the word bodies, I don't know why, but of humans or bodies working is okay into that mission.
You don't like the word bodies?
Well, I don't relate to it. It's not unlikable, it's just bodies you mean by humans.
Yeah. Yeah. I mean humans.
Yeah, I mean I like it. It just I couldn't understand the context.
Oh,
All this.
okay. Okay. Um. Oh, you didn't think it was like, oh, it's a bad way to talk about humans.
No, not
Oh,
really.
okay. Okay. Yeah.
I can joke. I can talk in many ways.
Okay. Okay. Um, yeah. Well, see, what you have is the ability to. So you've got enough numeracy to actually calculate and project, But I think the thing that's missing a lot, including the various people, including on the recent thing I mentioned about the house, people who see that and then they actually can't connect which is which. They're not really connecting the numbers, and then they get disillusioned. But yeah, it requires that you have a clear mind to actually understand the economics and stuff like that. So yeah, cool. So ultimately, number 12, ultimately discover your personal way that allows you to access unlimited, immediate information. Yeah, and I was alluding to that with access to the wiki or various genius networks and all that, but that's what every single person on this planet should feel like. Okay, I can access and learn and know any kind of power, any kind of capacity building. And that would be the mark of an open source world where we have shifted from like scarcity to abundance.
Sounds great. It's just, how do you reference that?
Um, well, sorry, how do I reference that? What?
Discover your personal way that allows you to unlimited immediate information. How? What example could really show this?
Well, like, like for example, I I go online right now and I get the full blueprints to build my skid steer that, or the rubber tire that pissed me off because it popped off the tractor and I spent like 2 hours trying to put it back on because we didn't have airless tires. That's a small example, but okay, I want that piece of information. Or how do I build the school? Like all the information like right now about how to start up the school that we're starting up, like really quality open info on how to do it. Well, it doesn't exist. Like I think so. The answer to that is easy on a point of like, I want to build my own car. Like I can't. I'd love to. I'd love to produce hydrogen because it's good for the environment and stuff like that. Or so for me, it's about very basic productive things that simply there's no access to me being able to build my own capacity. Like even grow food. Like I don't have the integrated machine set and skill set. I mean, we're working on it, but I can even grow my own food right now. That should be trivial. Like we should have, okay, here's the whole pattern, how you do everything, and easy accessible tool sets that anybody can then fend for themselves for freedom, right? For their livelihood. That's what it means to me.
What I understood it, and I believe it is something I want to do as well. But there's some information in the internet. If you want to fix a car, you can find some references. What is making this different? What is making this safer as number one option? Like if you're building a truck, that it's going to be for safe use. That would be my question. Because of references, the internet has some reference on different aspects, from building a house, from doing agriculture, from building some machinery. But this concept that you develop and many other people regarding open source and doing the blueprints, what makes it different?
Are you asking that question?
Yes.
That it's better, like cheaper, faster, more productive, more ecological, distributive of economic power. Like for example, I mean, we talked about the idea there is no best. Every person thinks that some different engine is the best, right? No, they're all crappy. They're not good. They're like, things are actually not that good as we think they are. They could be much better, right? So what's different? Well, for example, that like when my tractor broke, I would have been able to repair it with an off-the-shelf part in like an hour, as opposed to them taking 8 hours just to crack the tractor apart to fix it. It's super inefficient. I mean, everything is so extremely inefficient, comically inefficient, as said in one of the videos, Instagram. So is that clear?
Yes, that's clear the functionality that currently open source give you to understand the full components and be able to do it as fast as it can be, instead of making a lot of small decisions and not being able to do it direct, fast, and effective.
Or integrated, like integrated systems design, not just like individual things that are separated from everything. So I'm surprised. Were you asking this question like as a serious thing, like to clarify more of it? Because I think you know the answer to that, right? I mean,
Most of it, yes, but I was thinking of all the machinery that hasn't built yet.
but it's going to be the same thing as anything we're talking about, like right now, like what you're seeing with the blueberries, for example. It's like, okay, these pots are like that, but they last only so long. They have so much labor requirement. They're that expensive and stuff. So we're improving that, but you're questioning how that would apply to all the other things that we're going to build.
Yes, that was the part I didn't understand yet.
Okay. Well, what you will understand very soon, that it's pathetically inefficient everywhere. This is not a unique pattern. Like if you think like you can improve blueberry production, or like you can improve that tract or agriculture or whatever, the crappy design is a very persistent problem. So what is that? Remember one of the talks I said, what is that Metcalfe's law? What is it? Metcalfe? No. Sturgeon's law. Sorry. Remember Sturgeon's law?
No,
That's the
but
answer to your question in one line.
did you put it in the chat or
Yeah, hold on. Yeah, yeah, I'll put it in the chat. But yeah, take a look at that. Um, 90% of everything sucks. That's the bottom line. They even have a law for it. It's called Sturgeon's law.
Okay.
That is your answer. You'll find out that, oh yeah, in a car, yeah, it's like that too. We think that's the biggest myth in society. People think that things are already awesome. That's if you don't understand. Well, from an optimizer perspective, you got Metcalfe's law. The sucker or the average person or the person who did not look under the hood of the car, or proverbially, they think, oh yeah, everything is fine. But that's just a question of one's awareness, of how awake one is to possibility, right? Because I've looked deep into technology because I wanted technology to make me free. Like I started agriculture and I found out, I needed tools and skills. But then you start looking deeply into it, and pretty soon you start finding out that, holy cow, this really sucks. Like, why is this so bad? And it is so true. Like, right? I mean, you share that, right? You share that view. And
Yes, totally agree.
but you, for some reason, thought that did not apply to some things.
I couldn't connect
I
how
assure you, it applies to just about everything, man. Really. Like the more I find out, it's like, holy cow, I can't believe this. Like for example, with housing, holy cow, I can't believe like this is so expensive or so comically inefficient, or whatever. And the current crisis reflects that. It's like we officially call it a crisis, right? In the housing. So people are actually seeing that. Oh yeah, this is comically bad, right?
Yes.
Yeah. So anyway, that's so those are 12 items about thinking about how we learn rapidly. I don't know. Maybe as we go forward, maybe we can contribute to this page, or because I'm trying to get people to understand the pattern of how how to think, how to have a mental model that allows you to learn fast. And just like what we discovered right now, like you think, oh, that you thought it was okay. Well, part of it is understanding. Part of understanding reality or forming mental models is to be able to assess how good things are or how bad they are too. So that's all related to forming accurate mental models of reality. Now, but anyway, so let's move on. Let's go on from this aside.
Okay.
Okay. Okay.
Yeah.
All right. What are we talking about today then?
We can go to the work document, and I would say just focusing right now on the different structures, on the building strategy that is currently used, and then go from there to possible alternatives or innovations to get to near zero marginal cost on building sunshade and bird net,
Okay.
and then the rest of the materials. But today, I would be very happy if we just focus on structures.
Okay. So did you put together that thing about how this so structure for the bird netting and all that?
I did
Mm-hmm.
on the slide you are, like go to videos, so you can have a very clear definition of what the structure takes. So if you click on the first one, that's a video I took with a drone. Basically, there you can see the anchors, the post, the I forgot the word. It's not cemento. It's in Spanish would be
The cement basis. The
cement. Well, yes, the cement basis and the height of the post and different wires and rings in order to be able to put the bird net and sunshade. So if you're seeing the video,
yes, I am.
you should see what I
Yeah.
meant by this.
Posts are wood or steel.
These are wood, but they can be made of steel, or as an idea, they can be made of blocks if they're really cheap. It's
Blocks
just
or
a
just
structure.
3D printed. 3D printed potentially fiber reinforced 3D print. If we can
Yes,
master that technology, then we've got zero marginal cost on that.
I saw your WhatsApp message and about fiberglass. I did took a look, but I haven't yet connected how to apply it into this structure.
Yeah, so your print so the concept is you're 3D printing, but it's you have created 3D print filament that's got embedded a line of filament inside of it like fiberglass. So when you print with it, you print one continuous thing, like you print this post, maybe like lengthwise, go back and forth. So it's got plastic, but it's got reinforced carbon glass fiber in it. So it would be very strong, like stronger than the 5,000 psi plastic. Glass fiber is what, like 140,000 psi tensile strength. So
Okay,
yeah, okay. I watched the first video.
and the second video is just when it's finished, so you can see how it's finally structured. That's a
Uh
small
huh.
video, 20 seconds. You can see there the sunshade, which is about 4 meters, and bird net, which is at 5 meters altitude. Then on the,
$5 meters. Mm-hmm.
yeah, that's the measure of this. On the sides, you can see there is some bird net as well going into the floor to be fully closed. Those are the explanations of how this was made.
Yeah.
I tried to do it by video because I think video explains much more than words sometimes.
Yeah. Excellent. Yeah. So what do we want to discuss about this? How do we do this, and how do we do this better?
Correct. How do we decide this to get as low as cost and as safest as possible?
Labor or materials, both.
Both. I
Both.
think both can be done with good design.
Okay. Okay. Post
And
installation. How do you
one
install a
more thing,
post?
sorry. If you go to slide number 5, I did some images of
Mm-hmm.
what I meant last call. I said, what if we reduce the material? So here's the pictures
Ah.
of the
Okay.
technology.
Wow.
So if we talk about, let's say, a hectare, which is 10,000 square meters,
Yeah.
and we want to put burden, that would be the whole site. If we do this kind of strategy, this just goes into the line of plants, and that's much less square meters of material. And on the bird laser, which is on the right, instead of doing bird net of the whole area, this kind of green lasers has the capacity to reduce the number of birds around the plants, and it doesn't take much material. It just takes this technology.
How does it work?
It has certain scope where the laser is moving on around the plants. So if a bird gets close to the fruit, the laser is gonna pass over there, and the bird is just gonna fly away.
How reliable? I mean, for flocks of birds, like what's the real data on that? Do you have good familiarity with it?
Yes, if we go to slide number one, and we can see there the not explanation, but the website of the supplier.
So the bird laser 0.17 thing.
Yes, I put that cost, that's USD, 0.17 USD per square meter because of the laser capacity and scope. So this that we see in the picture, it's 12,000 USD, but has a minimum scope of 7 hectares. That's how I got per square meter cost of USD. And I did that in order to be able to compare it versus sunshade versus birdnet. And that's the minimum scope, 7 hectares. It says it goes even to double, at least to 15 hectares to 20 hectares. But I want to be very conservative. That's
Are
that's
you
where
okay
you
with?
can.
Are you okay with 90%?
For now, for analyzing, yes,
90%
because
bird reduction, so you can. How?
yes, because it's not that fruit risk is going to always be there. The real function of harvesting when it's mature, it's also to get the best flavor, but reduce the risk of birds. So as long as the fruit is ready, we don't leave it much there. So 90% should be big help.
Hmm.
Bird nets, honestly, yes, they're close and everything, but sometimes birds get in when labor is getting on the site and they leave the doors open. It's not very often that happens, so it's not 100% sure. Bird net.
So you're talking about 0.17 versus 0.15, but avoiding.
Well, yes, avoiding installation, avoiding maintenance. So we talked that bird net has
Ah.
the supplier says 5 years. That's what they give you warranty. The producer says 10 years, but sometimes producers, we don't want to spend too often what we already spend on materials. But let's say 5 years of the supplier. Plus, if you get a certain, the structure just gets unstitched, or maybe someone broke certain part of the door. That's those are different things that need to get accounted into maintenance cost. With laser, you don't get anything of this. You install the laser and you have a certain scope of area and you can work that constantly. The supplier says 10 years of the laser use. So that's already the double of what the BirdNet supplier is giving as warranty.
I missed. I was looking at the list. Double what? What's double?
Double the years of use with warranty versus using the BirdNet, which
Uh huh.
has only 5 years of warranty. That's another way of doing cost reference by number of years of use of this same setup.
So does 0.17 per meter squared already account for that? No. So it's 0.17. Literally, it's half of that for the 10 years, right?
0.17, I just did the reference of the total cost versus the area is gonna be
Oh,
used.
that's
I didn't put
just.
years.
So no years. So that's actually more attractive. It's already a better solution for the long term, right?
Yes.
Okay. So is the idea just to open source that thing?
Yes. If it's gonna be more cost effective than doing the BirdNet, yes.
Which it
But
already
still,
is.
already is. You talk about the effectiveness of 90%, and supposedly BirdNet its effectiveness of 98%, supposedly. Just winning that point as well. How do we maybe reduce the cost of the bird laser, and instead of doing 7 hectares as a minimal quote, we can reduce the number of hectares since the price is going to be reduced, and we can increase the number of percentage saved of fruit from the birds instead of 90 going into 99. Since the cost is going to be so attractive, we can do more lasers. That's something I wish we could get into.
Sure. So what's the key to that? Is the question would be, so it's positioning, detection, and laser source. So laser source. Do you know anything about the laser source? Is it just an LED? We have to look at what's the laser source. How is that an expensive part?
Well,
There's
you just click on the first slide where it says bird laser, second bubble to the right on concept one. Bird laser 0.17 per
Yep.
meter, and it's
Yep.
going to open.
Yep, I'm looking at that.
Yep. And
So let's start taking a look at that in detail. So let's see if we can do this. So so the question is, here you're open sourcing a product. What do? Design rationale. You look at requirements, design rationale. What is the design rationale for this thing? How does it work? How does it work? What's the physics there? Laser source, it's got 5,000 hours laser source. It sounds like if it's 5,000 hours, how long does an LED last? Okay, so it's not an LED. LEDs have 25,000 to 50,000 hours. If the laser is 5,000 hours, it's a laser. It's an actual laser. Sounds like. So it sounds like a laser. How much is this laser? It's from the Netherlands.
The price of this laser is 12,000 USD.
No, but I'm saying the laser element.
Oh, okay. Not sure.
Because what if you take that laser element and put it on an open source robotic arm or something for the directionality? No, you got the precision motion control with angles. That's relevant to shooting down drones, like in Ukraine as well. We could do dual use here.
Yes.
Once we get to shoot down airplanes. Okay. From the Russians. Okay. Let's see what we got. No, it doesn't tell you. Of course, it doesn't. So this isn't the answer to your question. Like, what's wrong with this? Well, it's not open source. Yeah. If it were open source, anyone could do it, and costs would go down.
Sorry.
Go ahead.
I'm gonna look for some documents of academic documents because I believe that for sure there might be reference on the internet. It's just that these technical details I downloaded from the commercial website of these sellers. So of course they're not gonna tell their technologies.
Well, once we start competing with them, they will.
Yes.
Open source. Bird laser. I would say, like, the first thing I ever do whenever I do something is I just Google open source bird laser, and if it comes, sometimes you'd be surprised what you find in an open source. So let's do a slide. Just start taking notes. So how it works.
I found some GitHub here. Arduino laser bird rep link.
Okay, paste it in on page 1.
Yes.
How it works. And this is perfect for ChatGPT. Source bird laser.
Do you use only ChatGPT or do you use
Ah,
Claude
I've
sometimes?
just been on chat. That's the only thing I needed so far. I never got anywhere that I didn't was stuck and I needed more yet. Green laser. Okay, so 532 nm laser beam, about 100 watts. Yeah, of course. We'll build this for $1,000 or a couple of $1,000. So let's see. So how much does a 532 nanometer laser at 100 watts cost? Class 3B for outdoor agricultural use. Okay, sure. So I'm going to share this immediately so you can take a look at chat.
Yes.
So you could do one as a sweep, and two is actual detection. So one is just, oh yeah, you just move it around and shake anybody that comes around, or you actually detect. Well, if you got the open source Arduino project, then we're halfway there.
It has computer vision capacity.
No, you don't have to have vision. You can just scan and just shoot everything in sight. That'll be version 1. You know, just start shooting the shit everywhere. Let's see. Let's see. So how much is a 100 watt? How much is that laser? My guess is it's $1,000. No, it's only $110. So there you go. No, no, wait, 100 watt. Let's see. 110. Green fiber couple laser system PC control customized laser.
Were you able to find the quote just of the cost of the laser? I have found commercial quotes, but
No, not yet. So I'm gonna retract the 100-watt laser. It's not a 100-watt laser power. It's the power supply. Therefore, the power of the laser itself is going to be like probably like 20% of that. Let me see how efficient is a 532 in terms of power out to power in. My guess it's like 20%, like 10% to 20% is a good figure for any efficiency. So let's see. Okay, diodes are like 30 to 50% efficient. Overall wall plug-in efficiency is like 10 to 20%. Yeah, that's what I said already. So yeah, so the actual laser power is like we're looking for say about a 10 to 20 watt laser itself. It will use more power, like 100 watts. So it's not the high-end spec laser. If we believe the power consumption of 100 watts, that means the laser itself is like, say, 15 watts for the laser itself.
okay. Yeah, that's a relationship of power to laser output.
Yeah. So efficiency of a laser. Let me share that. Laser efficiency, it's, let's say, 10 to 15%. Let's say 15%.
That's what I got as well on the chat.
Okay. Yep. Okay, so now let's start Googling for 15 watt 532 nanometer laser. So you could get very tiny ones, like it's going to be hard because this looks like nothing comes up quickly off the shelf. Let's ask chat. Okay, so give me a link. How do the birds get scared by the green laser? Does it like fry them, or does it like?
No, it's just certain discomfort they get through the eyes of the green color.
Uh-huh.
That's what I understood in the video. I'm not 100% sure. About lasers, on the other technology, the CNC machining, they use lasers. Are there any websites that you know that they talk about the different lasers,
Yeah,
pricing?
so those are going to be different lasers, different wavelengths, so they'll be different. But yeah, you can get yeah, you actually can do that. So let's look at 100 watt CO2 laser head. Yeah, those are like for CO2, those are like these glass tubes and they're only like $500. So that's different. Oh man, if it's for real, like you can get an 80-watt laser for $100. This is for CNC. Wow, the price has dropped way since the last time I looked. These things used to be like hundreds or thousands. Okay, but yeah, let's do.
The idea is not cutting or burning anything. As I understand, it's just a reflection on the vision of the animal that they just don't like it much.
Yeah. So there is one from Civil Laser. Wait, but that's 520 nanometer. That thing costs $4,000. But that's a little different. Let's not get discouraged. Well, I mean, look at my link that I already put in there for the example one. That shows $110 for
Civil laser.
it's set, but it's 1 to 100. But what is 110 for? What power? Well, if it's 1 watt and we need 15 watts, then we're still only at $1,600. So we're still like, you know, almost 10x lower cost. Wait, that's just the deposit, not the final price.
Yeah, I'm looking.
Yeah.
It's 600, 663.
Show me.
I'm gonna put it in the work document.
The Arduino laser thing is that link didn't work for me.
Okay, I'll check it now. I'm just pasting the 600 laser. I put it on number 2 efficiency off a laser.
Okay, but you didn't read it correctly. It's 100 milliwatt, not 100 watts. So 100 milliwatts, that's zero point 0.1 watt. So that doesn't look good. You know what I mean?
Yes.
We gotta go bigger. 10 milliwatt, 10 watt green laser. Yeah, it looks like a specialty thing. 532 nanometer.
Did the link work now on the GitHub?
Yeah. Okay. So what are they doing there? Oh, cool. Okay, there you go. They got this little. Yeah, that's what it is now. It's about scaling that up. I don't know if you can make this work.
The challenge here would be finding the cost of the laser. The rest is just automation that already exists. Is that correct?
Yeah. Now the automation exists. However, you will need precision on that. So that's the difference between that and being adding more cost to that. Yeah. Now, if that thing says that thing is good for 7 hectares, if you scale the power down Okay, say you've got 7 hectares, you're in the middle of 7 hectares or like 10. So that's a distance of, okay, let's just take a, okay, so let's scale like the little ones. Maybe what if we do a bunch of very little ones for a much smaller area, and these are, for example, 100 milliwatts for $25.
That's another option for sure. And the 7 hectares you're mentioning, it's just the lowest scope. They say minimum 7 hectares, average 50 hectares, max 30 hectares. So your idea makes a lot of sense of scaling down and being able to find cheaper prices, but be more productive in a reduced area.
Yeah. Yeah, get a bunch of them, and that's more modular. How do you do 50 hectares with that? That sounds impossible.
There's 30 hectares, it was the max.
How many?
30, 30,
30. An average was how much? 1.5.
15, 15, yes. But I would say doing something even for 5 hectare modules would be more than enough.
Well, if you scale the 100 milliwatts, that's 0.1 watt, you would need 150 of those. But 150 still costs, what, like 3,000 about? $3,000? 25 times 150.
$3,750.
Mm-hmm.
And the calculation we just did, what's the relationship?
Yeah, for the same power as the other one. So let's say it's average 15 hectares.
Okay.
So one of the tiny ones for $25 gets you 1/10 of a hectare. So $25 for 1/10.
So it would be 250 USD for a full hectare
Yeah.
versus the bird net, which is 0.15 times 10,000. It's 1,500, the bird net,
Yeah.
versus 50. So in that laser design, it's winning now on cost structure.
Yeah. Yeah, I mean, we can start with a GitHub project there, interestingly. Whoever did that, who did that? One way to go about it is, let's see, who is this guy?
Ron David, I don't know.
Yeah, we'll contact him potentially and see if he actually can do a more complicated one. Maybe more power. But the first thing is how well does that thing work already? Like, does it do anything? Does he have any? Let's see what. He's got a video there, but let's see. Does he have any?
He's just using it for his window with a very close distance.
Yeah. Yeah. It may not do anything. Or potentially. Yeah, I mean, so that's a development project and a half, right? So is that something to focus on?
Yes, but I just want to make sure if the current BirdNet with a different way of building the structure could also be a more cost-effective alternative.
Yeah. So right now we just discovered that, yeah, potentially this could be cost effective based on just the cost of the laser itself. And then you've got CNC, just the precision motion control that you need on top of that. It's possibly doable, yeah.
Yes.
Now, what do we do to reduce the netting itself cost? I mean, once again, the standard thing is what I could imagine immediately, just in my mind, is I would picture there's helical piers. That's a known technology. You know helical piers?
No.
Or metal with a screw on the bottom that you screw in for foundations. So if your bird post is that, and you're screwing it in automatically with a tractor one by one,
Okay.
that would do that. That would solve that. Now it might. At what cost? Like if you could 3D print that kind of stuff, that would be attractive. But if not, what you could possibly do is, I would say like you could, if you go through enough effort, you could definitely automate it. So even if it's plastic, fiber reinforced plastic, or even regular plastic, like if you print a tall tower out of something like ABS or PVC, then you can screw it in automatically with a tractor. Like so, it's got a auger. Think of an auger. A helical pier is a post with flighting. So helical, just Google helical pier. And so do that, a small one that's strong enough for the bird netting stuff.
It's helical and
Pier.
pier. ER. Okay. Okay. I see it.
Yeah, those kinds of things. So if you could 3D print it now, a 3D printed one that wouldn't go through rocky soil, but if you prepare the soil, like if you say that you
With the drilling.
let me ask you this: for the holes for the posts that you do concrete there. How do you dig the holes?
On the videos I sent, it was people, but there's machinery that do hole drilling with the tractor, and that's the easiest option. We have used that for planting pecan trees. That's where I got the relationship of it can be done with people, like we did on this sunshade structure, but it also can be done with a hole driller that it's attached to a tractor.
Yeah, I would see a post hole digger plus. If you have a post hole that's tight, you just stick your 3D printed thing in there. There you go. If you could 3D print it, what's one of the posts, the wooden posts cost you?
I don't have the price now, but I will put it in the document to answer.
Yeah, to take a look at that. I mean, once again, like you can see full automation. So you got drilling and then sticking that thing in. Even if you have your remote control tractor, so just you start the thing. It's kind of autonomous, almost autonomous. You can program it to go, dig hole, move on, dig hole. You can automate that fully. Then you stick the pier structure, the post in, which makes me question like why, if you're gonna dig deeper, like a longer hole, then Do you need that concrete there? Not sure. Possibly, but if the post is long enough, you don't need any concrete.
I would say probably not because the weight of the laser is not going to be that heavy. And the reason that these posts are made with concrete as an anchor is because they're going to be holding the whole sunshade and the whole burnet. So they need more structure to hold the pressure. That's my perspective. Not 100% sure about it.
Yeah, I could see you beating the economics if the posts you do. You want them to be long lifetime? Do you have to replace the posts every so often? Or do the posts live forever?
I wouldn't say forever, but at least for 15 years of the project.
Yeah.
We don't get that much wind. I mean,
Yeah.
the fastest we get is maybe 10 kilometers per hour. That's it.
Okay. So the only thing I can think about there is if we look into the printing, like real technologies for printing of the net using fiber reinforced printing and then fiber reinforced posts, you can just stick those in with a digger and then you have an easier way to do it. Now, how do you do the ropes? Does anyone use actual like plastic, like whatever, polyester or nylon ropes or anything? It's always metal, or
Could be different materials. What I have seen is metal, but for sure about the those ropes you mentioned,
mm-hmm.
they could work as well. I don't see why not.
Yeah. Yeah, okay. So it would take a little bit of work to actually go through the numbers. Do you want to do that for next time? Like, actually look at, okay, if you have the material costs, imagine we could get the prediction of fiber reinforced 3D printing. Like, assume we get that done. Like, because I mean, if we invest into it, we can get it done. I don't think it's physically, like, I don't see anything particularly super challenging about it. It's a machine where you're, it's where you take a filament strand and you melt it partly and then you're just sticking the filament into it, like the picture I showed you from Dr. Pierce. That's what
Yes,
that little machine does. You're just sticking a wire, embedding a wire into this filament. So, I mean, it's an engineering project. I haven't looked into the details of blocks, but I think anything is doable until proven otherwise. Let's see. Do commercial fiber-filled fiber? Let's see. Do commercial. If a commercial version of that already exists, then we know that actually is feasible and economically possible. So let's take a look at. Let's do a new chat.
yeah.
Let's ask.
You ask if I want to do it. Yes, is the highest cost they had on the structure now, on the whole system. This is the highest cost.
Mm-hmm.
So yes,
Yeah. 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 I mean, we could. So we could do side by side comparison of assuming that we've got a laser at the cost that we described. It's already proving feasible. The question is, can we get I mean, we'd have to do more development on both sides, but let's ask is let's see, is continuous glass fiber 3D printed material available? I don't think I really need to ask that. There's nothing physically, like just from first principles, difficult about embedding a piece of string inside plastic.
the helicopters you were mentioning about, you're thinking that this could be of fiberglass.
Yeah, make fiberglass posts like that. But even if you can't, like you do that flighting, that structure down there, even if you just bury that, then you can design the base of it, the helix, or whatever structure is down there in such a way that just burying with soil is sufficient instead of concrete. So you're not spending concrete, you're just backfilling it. That's what I'm thinking.
Okay.
So there's a 3D. Let's see. Yeah, like for example, National University of Science and Technology in the United Arab Emirates has done fiber reinforced 3D printing filament that's continuous. Yeah. Yeah, they've done. I wonder if they would share. So there's a paper. Okay. Yes, fiber filament, continuous fiber filament is possible. Let's go to yes. Now that's actually, I mean, that's our answer right there. Dr. Pierce is already working on it. Let's talk to him. Right?
Yes, I think that would be a next step, and also understanding what he has worked about the tunnels you were talking about.
Yep.
His designing.
Tunnels.
That
Tunnels. What about the tunnels?
you mentioned he has been working on microtunnels for agriculture.
Yeah, yeah. For this is for northern temperature, cold temperature, so highly insulated tunnels. Yes. How is
Maybe
that?
they're relevant. Maybe there is some structure design that can be adapted to this, that it's cost effective.
But structure that is, you're talking with respect to the bird netting aspect, the bird proof.
Yes, I understand these are insulated, but what I'm talking about is it has to have a structure that is defining the height, that is defining how much is built on the tunnel. Maybe post, maybe anchors. That's what I meant into his insulated project. Maybe we can take some of the structure he's using that could be cost effective already. That's
No,
what I
but
meant.
the problem is he's not. He's buying the structure, so that's not.
Oh,
We
okay.
don't have that. We don't have open source structure. We have the open source system integration. In other words, this is all proprietary hardware, but the design is open. That's the typical problem with open hardware. Like if I build my tractor, well, it's an open source design, but all the hardware I use is proprietary, like the hydraulic motors, engines. You know what I mean?
Yes.
That's the issue. So I don't think we have much there. But if you come to think about it, what if we just 3D print? How big are the birds? Those little bums that eat your blueberries. How big are they? What do you
Mm,
need? Is half inch, 1 inch, like 2.5 centimeters big enough?
I'm just gonna reference it in the chat because there are doves and there are black crows.
Now, obviously, they have to be. What's the smallest bird that you have to watch out for? Like tiny, like
No, the main three are doves and black crows, and I forgot the name of the other one, but
well,
they're the same size. 50 centimeters, about 60 to 21 inch. That's the size of each bird.
whoa. So why don't we just 3D print like a supportable Oh, then because the idea of a tunnel, like just print rings that are just over the whole plants for each row. So microtunnels. And those things ain't getting in there.
How would be the height of it? I'm thinking about, I mean, irrigation. It has already the fertilizers that it needs, but sometimes there's need to be foliar applications. So if we are thinking about this burnet tunnel structure you're talking about,
Mm-hmm.
how would that be the way to do it in your perspective?
Integrate the emitters into the inside that structure because it's all 3D printed. In fact, it could be part of your pot. So it's a
The
pot
meters,
with a big, big cover.
well, yes. And when it's time to harvest, and we want to use the mechanical
Yeah,
harvester,
mechanical
we just
harvester.
take it
So
away.
yeah, so you have to put it away. So how does that work? Let's see. Yeah, you'd have to remove it.
And that's labor.
That's work. Yes, yes, I see that. So is there any way to remove that? Because now I'm seeing, yeah, with zero marginal cost 3D printing filament, yeah, we could do that. It seems like just off the top of my head. Um, it would be interesting if you could have. Oh yeah, here we go. So you've got one one long line of wire. So the whole thing just lifts up. So it's a cap, but it just lifts up because you got tall poles. Um, no, I mean then you have to actually look at. So it's a structural engineering optimization problem. So using the least printing filament to get you that structure, you could definitely think of if it's lifted, you can lift it right up. If you don't have heavy winds, that's feasible. I mean, if you have heavy winds, then you got to do a lot of anchoring. But even anchoring, if you put it down and you put a pin, like with your little pin robot, just puts a pin every few meters or something, that could be doable too. Like you're pinning it down. But I could definitely. So how tall are the plants? They're all together.
Not more than 2.5. So we're talking about the design of the mechanical
Yeah.
harvester. They're asking no more than 2.5. So that could be a reference to use
So the plants that you have, they get up to 2.5.
at max.
But does that include pot?
Yes, all of it.
If you bury the pot, you're at 2 meters. Because what I'm thinking, like soil, like with abundant energy, which is solar, which you could do, you can dig soil so you can bury these things, bury the pots, or like recess them in the ground. I think you could possibly do that. Yeah. Then you can think about, if you have the ability to just crank out brick, like compressed earth block, that you've got these two long walls along the rows, you can put a smaller structure across them too. But I don't know, like the cranking out brick, they're not water resistant unless you stabilize them with concrete. So that's a hard
You,
sell.
you you go
But
to the slide 6, and we see again the open and close system. Instead of this post, you were mentioning putting the earth blocks. That was your way of thinking.
I was thinking, so along you've got a row of plants, but on each side you've got a small stem wall, small walls on each side. So if you need to cover them, you're literally got much less. You just have much less volume of, like it could be just a hoop that's much smaller because you got the wall of the compressed earth block. So that's what I was thinking.
Could be a possibility.
Yeah,
It would
that's
make
kind
the
of
calculation.
not sure how that would work. But something along with, I mean, for the netting itself, Um, they're definitely worth thinking about integrated netting slash shade, right? But that product doesn't exist because you want to have the netting on all the time. Is that what was the
Yes,
logic why they can be both in one? Because you
they
want to
can
take
be,
off.
well, they can be both in one, but it's better in some climates when it's not much sun to be able to make it retractable, meaning that moving the sunshade so it gets more sun hours, let's
Yeah,
say on the plant stages that
yeah.
benefit from this as the harvesting time. But if we're talking about structure, and I'm just thinking loud, and we do a fixed structure, and we find a low cost of using LEDs and solar panels, that time when the plant need more light, that can be done with LED lights instead of doing the retractable sunshade.
Oh, yeah.
There
Oh,
we
there you
can
go.
do the cycle that it's going to be cost effective and also productive since it's fixed, but we have LED lights to be able to give more light when they need most. If we get that
Oh,
cost right, that can be fixed and more productive.
yep. That's interesting thinking. Yeah, yeah, yeah. I like it. Um, so you 3D print the sunshade slash bird net to get more light. It's LEDs. Yeah, we'd have to look at the details of that.
And we will have a fixed structure. That's why I mentioned I want to focus on structures because I was also
Mm-hmm.
thinking on the sides, that greenhouses get hot and
Yeah.
we use earth block. Maybe that's going to be an effect like the adobe houses we were mentioning last call that they refresh inside instead of being so hot in the summers and doing these open structures. Maybe using some earth blocks could give better airflow inside the fixed structure. Did I explain clearly or
Yeah, I think so. I think I've got what I need. Now, if you talk about structures, then you got to be talking about space frames or domes. That's going to be the thing then. If you want structure that's dome like structures like Buckminster Fuller style kind of stuff, which is space frames. That also is another type of space frame. Yeah, that would be because that you could 3D print. You can 3D print all the members, or you can 3D print connectors for other members. Um, if you talk about retracting those, then you can be talking about lifting them, possibly lift. If they're linear things, then you can lift them, like lift the whole row for say harvest. Um,
that kind of design? I
yeah,
know which one you're talking about. Is just if we say the efficiency of being able to have straight lines and being able to harvest straight, how can we achieve that with a bulk type of design?
yeah,
But
you'd have to make an elongated dome. So I'm still talking about elongated domes. Yeah, so basically linear domes. Yeah,
okay, could be
yeah,
an option.
yeah, yeah. I mean that's the most efficient way to get space covered. Okay, so let's talk about next time. I got to get going. So we've got crunch. So on our side here, man, we got like 40 people already signed up for the Builder Crash Course. It's really good. We're gonna kick some ass in it. We're building a big hangar structure, so I'm out there grading every day and thinking about how to automate all of that because it's just ridiculous. And people are still getting abused grading and doing all that manually. That's just we've got all. I think it's ridiculous. It's definitely Sturgeon's law territory, and I'm part of it right until we fix it, right?
Yes.
So, but
No, no,
that's why I like getting out there to get abused because I get reminded of how ridiculous this is. So I've got emotional intelligence to fix it or moral intelligence to fix it. Yeah.
yes, I laugh because it happens to me as well. Right now, I used to have a lot of employees, and now I'm reducing the labor I need,
Mm-hmm.
especially in blueberry project because I get to do it with my own hands, and what I don't like, I try to change it. It's expensive, I try to do it low cost. I
That's the
think
only
that's
way.
good.
Yeah, no, that's good. That's the only way. I mean, that's the accountable way. You got to do all those steps so you appreciate the full system. This thing never got fixed because the whole systems are disintegrated. Yeah, yeah. Okay.
So for next time,
Yeah.
you tell me if you need something specific, or I could just work on having the full information from the past calls and just check it next time. If
Let's
you're
start.
going to be busy, it's okay.
Um, what if I can't make it? You saying?
Yeah. So you have the builder's course
Yeah, we're
soon.
crunch time. Yeah, it's December 1, so I'm still digging out there to build it because we
Uh,
want to have this whole thing, whole structure. We've got all the modules built. We got to install it, and we got to put 100 kilowatts of PV on it. So it's big. Um, okay, no, let's check in next week, but check in like real quick, like a short meeting. But let's start nailing down the prices. Like start going through. I'll reach out to Joshua to see what their progress is or what it would take to do the filament embedded thing. But that's a thing where we got to be thinking about spending money on that. Like if he needs graduate students to do that, we should fund them. And to fund them, I know I could build a house to fund them. I just need humans, that kind of stuff. That's how I think. It's like we got to get this viral video for the apprenticeship where we get 100 applicants and we get 24 like by February and then 240 by 12 months. That's how I'm thinking about it right now. 12 to 240 to I mentioned 1,000. So 50 times 24. I think that's a good number. That's we're going to max out this facility here. But that's my mindset right now. Masses of applicants. We need that. Because we got to fund all this, like all this stuff here. You're talking about every single thing here. We're talking about is a life project for a single person, right? So we need humans, we need the bodies to make it happen. And the cool thing about it is that it doesn't take a lot of energy to do it. It's like say $1 million a pop for a technology or 50 billion for the technosphere. I mean that's a tiny fraction of what's out there. So it's quite doable. It's the proposition is not crazy. It's about getting to execute on this. Mm-hmm.
So can we do a 20 minutes next time just to reference the cost of everything we have talked about, and then we can build from there in 15 days.
Yeah, let's do that. So meet next week for a little bit of time.
Yeah, 20 minutes should be okay.
Yeah, just go over that. But what we got to be doing is just going the numbers like pick a waste stream source of plastic. So just take 14 cents per kilogram TPU waste stream. Just take that assumption and say, okay, if I wanted to build this dome structure, like however I do it, just start counting. So what's the weight of it? I told you already you could get the weights of 3D prints from various softwares, like either slicing software or just whatever, online calculators. How much material does this take? And start getting numbers. Okay, to get a meter of this structure, it would cost me this. But somehow I think you got to think about the posts where we can, the most lightweight space frame structures, whether it's like think of it like a Bucky dome, elongated, but the windows are closed, but closed with mesh. So, enough size. I mean, do you think like 10 centimeters would be 5 centimeters? Would that be enough to close off all the birds, or there's birds smaller than 5 centimeters that can get in?
Just gonna take the current bird net, and it says
Those are tiny bird nets. Those are like 2 centimeters.
probably 2 centimeters.
Yeah,
5
they're tiny. So, but we don't have to. We can go larger. And if you think about actual, like, just do a basic calculation for if say you've got a Bucky dome that's made of just hollow PVC, hollow plastic. Just start getting ideas of how much that would weigh. So it's just a little counting.
Okay.
And then attach a cost to it. This would cost me X per assume it like you got a Bucky Dome linear tunnel. Just make some assumptions. Here's my tube members. Here's how thick, big they are. Maybe they're like 2 centimeters. They're hollow or whatever they are, and start getting those answers. And then the optimization probably, I suspect, comes from if embedding, like, say, the fibers in it, so you can use much less material. It could be the PV, it could be the bird laser, it could be whatever. We've got a lot of options, but let's just get some baselines for, okay, here's the basic cost per meter of that. Like, for example, even the brick wall. Like, I have thought about, like, I told you about Chinese greenhouses, right?
Yes.
Just do the CEB walls. I can tell you right now that I do want to do CEB greenhouses, but that's just for small, like 100 square meters, whatever, that kind of stuff. But now if we've got solar energy to run the brick press, then you can do it at scale, because you got dirt for free.
Yes.
So think about automated laying of blocks, so you can really create big walls. But ask, how much does that cost you? That will be time, amount of machines, just time, machines, like the capital for the machines, capital for the PV that runs that, which will be minimal. But just get those baseline zero marginal cost numbers. So we're doing zero marginal cost analysis. It's going to be a new thing they're going to teach at Harvard school, whatever, at the top business schools.
Yeah,
Zero marginal cost economics. Yeah.
Okay, and just one last thing about the energy. I was thinking about water desalination, and also, so you get the pure water, but you also get the discharge water, which is full of salt or sodium. I was looking about the sodium batteries as an alternative option to get even cheaper energy. So you have the strategy of thermal energy. Can we take the salt of the desalination water and make components for sodium batteries? Does that make any sense, or it's too complicated?
Yeah, I don't know about it. I would doubt, because of the, if you think about photovoltaics, that's rocks, that's sand, that's turned into electricity. I'm not sure you're going to do better than sand turned into electricity. I mean, we can go through those numbers, but I have not seen evidence yet. So you're talking about some batteries that are chemical batteries?
Lithium? That's an alternative. Well, that's what I saw. Instead of using lithium, I saw an article that they are changing into using sodium.
Sodium, yeah.
Yeah.
Yeah, that's. We can look into that. That would be far out. That's hard. That sounds hard. I don't know how hard it is, but for now, like, I think we can look at some basics of it. If you have any numbers on that, yeah, take a look at that. Definitely consider it. Like, what are the baseline material costs and production costs? But I think a lot of times we don't have to look further. Like, we already have PV and we already have 3D printing and we have waste plastic. Like, I'm not sure we need to look any further than that at this point.
I'm sure we don't. I was just thinking about if we start desalinating big amounts of water, there's going to be big amounts of salts that needs to be discharged somewhere. And as a solution, I say, what if we take this salt and we turn it into a component for these new batteries that are already developing in the market instead of lithium batteries? That was my approach of not doing any, do not do any harm into the ecosystem. That's why I want to do something with salt.
Well, I can tell you that my first thing I would do is I would make salt, not salt batteries, not sodium batteries, but just sodium chloride as table salt, because that's a product.
I'm aware, but in the water desalination, sometimes there are salt, yes, but also other substances that I don't know, for human consumption, it's going to be the best. That's why I want chemicals.
Yeah, exactly. But that's the reason why also for the lithium that will be a challenge. Probably will be a challenge for that even more. You know what I mean?
Okay.
Maybe not. But from first principles, I would say, well, if it's a problem for just making regular salt, it will be a bigger problem for something that's much more complicated. Probably, but maybe not.
Okay. Yeah, just
what do you do with the?
Sorry.
What do they do with the brine, the wastewater at this point?
They put it back into the systems, into the water systems, into the drainage systems, and back to the sea. So that's why desalination maybe it's getting a better cost, but the drainage, what's putting back into the system, is unbalancing everything.
So they're killing off the rivers and all that.
Probably in the future, I haven't seen that much
Yeah.
desalination, but that could be a possibility.
Okay. No, that's a real issue, and I think. Oh man, at that point it goes into. Huh, I don't see anything outside of big evaporation ponds. I mean, man, you just then collect all the salts and yeah, you're gonna have to deal with that. That's true though. Yeah, didn't think about the wastewater at all. But yeah, you're right because you got how many parts wastewater per? Is it more wastewater? Like
30%.
30% is waste.
Yes, on common systems. There are some called zero discharge systems that they're doing this absorption of even the minerals that are on that water, the salt,
Mm,
but that's very expensive as of now.
yeah. No, that's a real deal. And the way I think about it is, if you have low cost electricity for evaporating, then yeah, you're just taking the solids out, and then you've got that problem largely solved. I think because the volume of the evaporated water will be, just the salt itself will be very much smaller. Yeah.
That's what I believe. And for the current blueberry system, I don't see it as an issue, being honest, even if we grow to 1,000 hectares. But I'm talking in the future, if we want to
Yeah.
open this water desalination, we have to also propose a strategy for not making it cheap, but then making another problem because it's very cheap.
Yep. Yep.
That
Okay.
was my last question. I know it's late now, and we can talk next week if you are available.
Yeah, definitely. So let's check in next Tuesday, same time, and we'll take it from
Yeah,
here. All right.
see you soon.
See you
Bye.
soon. Bye bye.